Hi, I'm Satishar, final year student from the Department of Cybersecurity, final year. Our project title is Mobile Based Intervention for GDM Monitoring and Maternal Fetal Outcomes. Introduction. Gestational Diabetes Mellitus. This is a common pregnancy complication that affects maternal and fetal health among pregnant mothers. This GDM occurs when blood glucose levels rise during pregnancy because of the insulin resistance in pregnant mothers. An uncontrolled GDM can always lead to serious complications for both mother and baby. So, early monitoring and prevention is important. The problem statement is this requires continuous monitoring of blood sugar levels and lifestyle management. And so many mothers face difficulties in tracking glucose levels, maintaining diet routines, and attending regular follow ups, which increases health risks for both mother and baby. So, the purpose of this project is to develop a mobile mediated platform to support the pregnant mothers with GDM. The challenges includes lack of continuous monitoring and poor awareness among mothers about GDM, and the objective is to build a mobile mediated platform by enabling glucose tracking, reminders, health monitoring, education modules, and automated report generation for healthcare providers. The scope is to develop a web application for monitoring gestational diabetes mellitus, and we are going to take the data such as biochemical parameters and biophysical parameters. The target audience includes pregnant women with GDM, doctors, nurses, and healthcare institutions. Deliverables will be a functional web-based monitoring system with user-friendly dashboard for patients and clinicians as well. The data is included here is as a biochemical parameter, FBS and PPBS blood sugar tracking are included. And as a biophysical parameter, the pregnant woman's weight, BP, activities, diet, exercise activities, food activities are all monitored and entered into the website, and they can view it as a dashboard, and the clinicians can generate the report from it. So data collection. The patients enter glucose, diet, exercise, and biophysical data. Then the data is pre-processed for monitoring and analysis. It will track the trends and detect abnormal values. If abnormal values is detected, the alert will be automatically generated to the respective nurse and the doctor of the respective patient. The responsive dashboard shows what and all to do, and they can add clinical suggestions to. Functional requirements are user management, glucose monitoring, reminder system, health parameter tracking, educational module for GDM awareness, and report generation such as weekly health summaries and monthly report generation. Non-functional requirements were the web app's performance, the security by ensuring confidentiality of the patient's information, the usability, the reliability of the web app, the scalability, how many users can use it simultaneously, the compatibility across multiple devices and common operating systems. This is the architecture diagram where in the user end, the patient is going to log in and authenticate themselves, and they will be redirected to the home page. The home page contains data entry modules where they can enter their blood sugar intakes, food intakes, exercise activities, etc. And they can have monitoring and alert module, reports and graph generations, educational or awareness module, and these data are transferred to administrator and clinical end where each patient is assigned to the respective doctor and nurse. They can view patient's data, and they can view the alerts from the patient's data, and they can add the clinical suggestions to improve it, and they can generate the reports from the patient's data. And the admin's role is here to manage the user and doctor and nurse. They can assign the patient to respective doctor and nurse, and they manage the database and security. This is the use case diagram where patients users are enter blood sugar data, log food exercise, book appointments like that, and nurses are monitoring patient data and add care suggestions. Doctor do the same work of the nurse, and admin is managing user roles. This is the class diagram where four pillars are here: admin, doctor, patient, and nurse. This is how the sequence diagram, where how a website works in a sequential order. And the algorithms used here is rule-based algorithm, rule-based access control for secure data handling, automated report generation, data aggregation for weekly and monthly summaries, alert triggering for abnormal values, and rule-based threshold detection for glucose and BP. Tech stack. For the front end, I have used React.js and Next.js with TypeScript, Tailwind CSS for animation. For backend, I have used Next.js with API routes and TypeScript. For database, we have used Supabase, and for security, we used Java Web Tokens based authentication, HSTS, HTTPS, and SSL. For deployment, we hosted our website in Vercel. And now, coming to implementation, the project is implemented with a web-based architecture, and in this web interface, the patients can enter their blood glucose levels, food activities, exercise details, and biophysical parameters. The system processes the entered data and compares it with predefined medical threshold values. The monitoring logic categorizes the data into different health parameters based on the dataset rules. It displays the output in the form of graphs, alerts, and reports along with the parameter status. This is the user authentication using Supabase code and the patient health data entry. This contains user ID as string, FBS as a number, and PPBS as a number. Monitoring and report data fetching code. Role based access control. User role string allowed roles are based on patient, doctor, and nurse or admin. Alert trigger for abnormal values. If FBS value is greater than 95 or PPBS value is greater than 140, the alert is automatically generated as abnormal glucose level detected for both patients and doctors. Now let's go to the demo of project. This is the website's welcome page, and I'm going to sign in as a patient. So this is how the patient's dashboard looks like. They can track the data by entering the data in the track data section, and they can view their analytics here. Average glucose for the week, highest reading in the week, compliance rate, out of range days in the particular month, glucose trend by week, week 1, week 2, week 3, week 4, average and target is listed here. Distribution of the glucose level ranges, compliances, target and logged. The key insights will be delivered based on the readings, and appointments. They can book their appointments here. Routine checkup, blood work. When they click the book appointment section, they can click the appointment title, date, time, appointment type such as consultation, lab test, imaging, follow up, and location too. They can manage their alerts here. High glucose reading. Your glucose reading is 165 mg per dl. Please review your diet and contact your doctor if levels persist. And the alerts will be categorized as high, critical, normal, appointment reminder, weight gain alert, medication reminder. Like these alerts will be triggered. These critical reminders are uh, triggered for nurses and doctors too. They can add their clinical suggestions, and it will be again reflected on the patient's dashboard. And this is the chatbot to know about the GDM. And the learn section is specifically designed for all patients to learn about the GDM, the nutrition and diet for GDM mothers, safe exercises during pregnancy, monitoring their health, complications, and when to seek help, postpartum care, etc. etc. This will create more awareness on GDM mothers by reducing fear and reducing complications too. So this is the output. The website is tested on these five test cases: user registration, user login, glucose data entry, alert generation, and report generation. The results are: it allows mothers with GDM to regularly record and monitor their biochemical and biophysical parameters. This alert mechanism helps in early identification of abnormal glucose and blood pressure values, reducing the risk of complications. Doctors and nurses can effectively review patient data, analyze trends, and provide timely suggestions through reports and dashboards. So, overall, the system improves monitoring, consistency, self care adherence, and communication between patients and healthcare providers. The SDG goals include SDG 3 good health and well-being, promotes maternal health and fetal health. SDG 9 industry innovation and infrastructure utilizes digital health technologies to build an innovative and accessible mobile mediated platform for mothers with GDM. And SDG 10 reduced inequalities, provides equal access to health monitoring for all pregnant mothers. SDG for quality education enhances awareness through educational content about GDM management. And the SDG 17 partnership for the goals encourages collaboration between healthcare providers, developers, and medical institutions to improve digital maternal healthcare solutions. Conclusion: the proposed web based mobile mediated intervention system provides an effective platform for managing GDM. So, role based access for patients, doctors, and nurses ensures proper monitoring and coordination of care. Overall, this system contributes to improved maternal and fetal outcomes through enhanced awareness, adherence, and early intervention. Future The future can be enhanced by integrating smart glucometers for automatic glucose data collections, and AI techniques can be applied to predict glucose trends and provide personalized recommendations. Multilingual support can be added to improve accessibility for users from different regions. Video consultation and real time communication features can be added to strengthen remote healthcare support. These are the reference papers used here, and thank you.